As Abel said, my name is Cyndhia. I work as a staff scientist at Earth Justice, and I'll be providing just a very high-level overview of carbon capture storage to provide context for today's presentations by technical experts. So here's a quick outline. I'll introduce some of the acronyms and concepts around CCS, give you a picture of what a hub could look like. I'll talk about the CCS funding that's been infused in the US, and then I'll just show you some maps of the potential build out of CO2 pipelines and storage, and introduce the environmental justice concerns with this build out. And then we'll move on to our experts. So as many of us here are aware, there's general global consensus that we need to reduce greenhouse gas emissions from industry to prevent harm from climate change. There's a field called, this is kind of the umbrella term, this is called carbon management. And these are mostly approaches to reduce carbon dioxide emissions, mostly from the power and industrial sectors, as well as their legacy emissions. So you might have heard this term, and so I wanted to explain it here. Within carbon management, you kind of have two tactics. One is called carbon dioxide removal, or CDR, which are ways that remove the existing carbon dioxide from the atmosphere or the oceans. One that you might have already heard about is called direct air capture. And then today's focus is really about abating the CO2 emissions from the emission source, mostly from the power and industrial sectors. So this is generally called CCS. You might have heard CCU or CCUS, which are variations of the same idea. So those letters represent carbon capture. The U could be for use or utilization, and the S could stand for storage or sequestration. For simplicity, I'm just going to say CCS, but I really mean all of these letters. Here's a picture maybe that helps differentiate between those two acronyms. The carbon dioxide removal on the right from like trees or direct air capture versus carbon capture on the left, where you're preventing the CO2, where they propose to prevent the CO2 from entering the atmosphere from industry. This is a schematic of what a CCS hub could look like. It's a very idealized diagram, but just to help illustrate what the components are, the basic idea of a hub is the network of infrastructure that connects the facilities that emit CO2 and then transporting that captured CO2 to its eventual destination of getting used or stored. So in this particular diagram, you're seeing the extraction of oil gas on the left. You also see biomass and coal, which we're not focusing on today. Those are the feedstocks and fuel sources for the industrial sector. Then that captured CO2 from those facilities is transported, usually mostly by pipeline. So you can kind of think of those blue lines as the pipeline infrastructure building out. And then those pipelines would bring it to either uses or deep geological storage onshore as well as offshore, which is why you see the ship on the bottom left. So this was just to give you a general idea of a hub and all of the infrastructure that would be required to build this out. There's a lot of funding that's recently been infused to develop CCS in the country. So in November 2021, the Infrastructure Investments and Jobs Act was signed into law. And this allocates $12.1 billion towards CCS. And really, I should have said carbon management because it also includes direct air capture. But what I wanted to highlight here was that $4.5 billion is included to develop the carbon transportation and sequestration, which is the focus of today's workshop. I also included a bullet point about the hydrogen hubs. The hydrogen hubs won't necessarily include CCS, but they might. So I wanted to flag that for your awareness. And then a few months later, in August 2022, the Inflation Reduction Act was signed into law. And what this law adds is it adds 2 tax incentives that have implications for CCS. You've probably heard about them, the 45Q and the 45V. The 45Q tax credit is all about carbon sequestration. So it's some dollar amount per ton of sequestered carbon dioxide. And then the 45V tax credit, again, is about the hydrogen production, but because some of the hydrogen production might include CCS, I wanted to put it here again so that folks are aware of that. So to kind of introduce Dr. Steve Janstow's talk, this is a map of the existing network of CO2 pipelines. It's about 5,000 miles. The dark gray lines represent the CO2 pipelines that exist as of 2020. You'll notice there's a bunch around the Permian Basin in Texas, New Mexico, and there's the big Denbury pipeline between Mississippi, Louisiana, and Texas. Most of these pipelines are currently being used for enhanced oil recovery, and most of the source of that CO2 comes from natural sources. So that CO2 doesn't have too many contaminants. It's not coming from industry. And I think Dr. Janstow will talk about that a little more in his talk. Meanwhile, what's being proposed as far as the CO2 pipeline build out in the next several decades is massive. It would multiply the existing network 20 to 50 times. So this map is just an example. It's not what's actually being proposed, but this was just a rendering of what it could look like. And for some reason, it doesn't include the east and west coasts. But you see the lines the thickness of the lines are proportional to the capacity of the CO2 that could be transported. And then the different colored dots are the different types of facilities that would be emitting CO2. You'll notice there's a high concentration there along the Texas-Louisiana Gulf Coast, which we'll talk a little bit more about. And then for storage, this is a map showing, so the gray blobs are the potential storage capacity of CO2 that the USGS and other agencies have mapped out. And then the red circles represent the proposed CO2 storage sites that have been announced. So you'll notice many of those red circles are along the Texas-Louisiana Gulf Coast, some along the Central Valley of California, and a little bit in the Ohio River Valley. And then here, this is just a screenshot from EJ's screen. This is just one example of how to show environmental justice concerns. This is not all of them. I just picked the air toxics cancer risk indicator as an example. This shows that communities of color, low-income communities that are exposed to the highest cancer risk from air pollution are largely concentrated in the Gulf South. And also you'll see some of those red-orange colors in the Central Valley in California, as well as some dark gray dots in the Ohio River Valley. So those spots kind of represent higher risk. And if you remember from the previous maps, the CCS build out for both storage and pipelines is highly concentrated in these areas that are already experiencing heavy pollution. So what we really want to understand and help folks learn more about is the challenges and risks and impacts from the build out of all of this CCS infrastructure, which could largely happen in the same areas of heavy pollution. So with that, I'll pass it over to our 2 experts for today. Dr. Steve Janstow will talk about the CO2 transport via pipeline, and Dr. Dominic DiGiulio will talk about CO2 injection for storage and sequestration. Thank you so much.